forgot here. Video 3 now is junk. Video 4 is good.
Well,
So,
would you take the 18 to the side?
huh?
You wouldn't take the 18 out of there?
Out of here?
Yeah, like wouldn't that be a constant? You take that out, so it'd be 18 dx x over x squared plus 9 squared.
It still won't make a difference. In terms of taking the derivative, it's still going to be the same amount of work.
Okay.
So this will be the bottom times the derivative of the top minus the top, which is what? 18x times the derivative of the bottom. What's the derivative here? 2 times x squared plus 9 to the power of 1 times the derivative what's on the inside, which is what? 2x. The whole thing divided by x squared plus 9. When you square that, becomes what? 4th. Let me go to my calculator and see what the answer to that expression. With the answer being simplified, according to my friend here, the answer is negative 54 times x squared minus 3, they factor the negative 54 out, over x squared plus 9 to the 3rd power.
So there's no easy way to do that when we're doing the homework.
Unless you get a TI-89.
Get a TI-89.
You can't use it on the test.
Yeah.
But to do that on the TI-89, you go on F3, which gives you the derivative. I gotta wait till the camera's on. I'll do that later with the camera. Zoom in on it, show you. So you just gotta do the algebra and simplify it. So that's your derivative. The TI-83, by the way, takes the derivative. I just don't know how on it. That cheap calculator, but it does that. So is the 84. So there's my answer. Where is the second derivative equal to 0? Plus or minus, right? Yes.
How did you end up with x squared minus 3? What happened to the x squared minus 9?
Here?
Yeah.
Well, there's 2 here and there's 1 there. So you factor 1 out, that cancels 1 on the one on the bottom. That's why you have x squared plus 9 to the 3rd power. See how they answer?
And how did that reduce to x?
So you have only 1 x squared plus 9 times the 18. That's 18x squared plus 18 times 9. On that side, you're going to have 2x times 2 times negative 18x. So that's where it came from.
And then you square the whole thing after you multiply? Like say 18.
There's no squaring. Nope. There's no squaring. He's asking quickly. I'll look at that quickly. How did he go? So what they did, they took x squared plus 9 out as a factor. In the first one, what's left? Left the 18 and the x squared plus 9. Minus, I already factored this one out, so what's left there? The 18x times the 2 times the 2x. That's what they did. So this one actually cancels one of these, so it leaves me now with 3 of them in the bottom. That's 18x squared plus 9 times 18, which is a big number. 9 times 18, 162, minus 2 times 2, 4, 4 times 18, is that 72? Negative 72 x squared. Now, what's negative 72 plus 18? 54? So that's what they did. and they decide to factor the negative 54. That becomes a minus. What's 162 divided by 54? 3. So that's what the calculator did all these steps for me. I just don't want to do them. I end up doing them. I won't do them on the next one. I'll just say, okay, move on.
That's 16 squared over there?
That's 162.
Oh,
162.
Alright, so now we got to this point, what was the question again?
Now, we got the derivative.
Oh, yeah, 0 over d.
So we got that. And where's the derivative undefined? When the bottom is 0. And that will never happen. Never. Second derivative. The negative the square root of 3. Positive is square root of 3. Two numbers. Negative the square root of 3 and the positive the square root of 3. These are the critical value for the second derivative.
Oh,
The y value for that, if we need them, I don't know if they ask for them. They don't ask for them, actually. I don't have to find the y value. But usually you want to find the y. If you want to graph it, we're not graphing it here. They just want to know, where is it concave upward, where is it concave down. That's all they're asking. So I'm going to pick a number below the minus the square root of 3. How about a minus 2? Between this and that, how about a 0? More than the square root of 3, what about a 2? And what's the derivative of that? The second derivative. Negative 54 times 4 minus 3, that's a 1. Negative 2 squared is 4. 4 plus 9, which is what? There's going to be a positive in the bottom, regardless how you look at it. The bottom is always a plus. Because you're going to square the number and add 9 to it. Always a plus. Negative over positive, that's what? Negative. Concave downward, not upward. I drew an upward picture. This is the second derivative. The second derivative is less than 0. It's concave downward. The 0, negative 54 times a negative 3 over positive. That's positive over positive, which is positive. Concave upward. Inflection point right here. Change of concavity. They're not asking for that here. The 2. Negative 54 times 1 over positive. That's a negative. Concave downward. Inflection point again. Where's the function concave? Upward. Upward from where to where? That's all they're asking. Upward and downward. Upward from negative the square root of 3 all the way to the square root of 3. Downward. From where to where? From negative infinity to what? Negative the square root of 3. Or add to it, that's the u in set notation, square root of 3 to where? Infinity. These two pieces. So that's number 6. Number 17. F of x equals 7 sine of x plus sine 2x from 0 to 2 pi. And they wanted to know, find the points of inflection, find where the graph concave upward, find where the graph concave downward. That means the second derivative. First derivative, derivative sine is what? Cosine x. The derivative sine is what? Cosine 2x times the derivative 2x, which is what? 2. The second derivative. That's the derivative of this. What's the derivative of cosine? Negative sine. This will be a minus. Derivative of cosine is negative. That will be 4 sine 2x. This will never be undefined. Sine always has a value. So the derivative equal to 0. Negative 7 sine of x equals 4 sine 2x. Now you got a little problem. This is x and this is 2x. You really can't solve them unless you know some trig identities. I looked at the board to see if it's still there. Who was in my Tech Math 2 last semester? Nobody? In my Tech Math 2, when I did Tech Math 2, one of the trig identities, sine 2x, is 2 sine of x cosine x. Now you gotta solve it. I should have left them on one side. That should be easier. I'll put them back on one side. I'm bringing them back to one side. I'm going to replace sine 2x with what? 2 sine of x cosine x. I went back to this step here. Using that, I put it there to see if I can solve it. I realize this is x and that's 2x. I can't solve it. So I'm using that substitution, putting it back in that form. So I can factor sine x out. Negative 7 left here, minus what? 8 cosine of x is equal to 0. The only way that derivative will equal to 0 of what? If sine of x is equal to 0, or negative 7 minus 8 cosine x is equal to 0. That's the only way you'll have a 0. If this piece is 0 or that piece is 0. So sine of x equals 0. If I clean this one, that's what? 8 cosine x equals negative 7. Cosine x equals negative 7 over 8.
Wouldn't that be positive 7?
I moved this one actually to that side. One is positive, one is negative. Now, sine of what is 0 degree? 0 or what? pi. Between 0 and 2 pi, 0 and pi. Well, 0 is one of the endpoints, so I don't have to worry about it. Cosine equals negative 7 over 8. What's x? The inverse cosine of negative 7 over 8. So make sure you calculate in radian mode, not degree mode. Make sure it's radian, yep. Negative, or inverse cosine, not negative. Inverse cosine of negative 7 divided by 8. I get 2.636. And there's another number, actually, by the way, where the cosine is negative. What's the other value? All students take calculus. All stores take cash. All students try chicken. Whatever you want it to be. So now, this is pi over 2. This is pi. Number-wise, what's pi over 2?
0 and 1.
Pi divided by 2 is 1.57. This is 3.14. So the 2.63 is somewhere here, in this quadrant. We have another angle we need to find. And that angle, if you take that paper and fold it now along the x-axis. So we have another one right here. And what is that angle? So the first piece here, this was 2.636. What is that piece?
5 plus that number.
What is it?
5 plus that number.
5? How'd you get the 5?
No, pi.
Pi. I don't think so. Pi plus that number? No. How about if you went all the way here? What's that? 2 pi minus 2.63. Yep. So 2 pi minus 2.636. 3.647. $3.647. So now here we go. Second derivative. I finish all my points. I get all my pieces. There's my box. This is the 0. This is the 2 pi. That's how far are we going. Let's see. Sine equals to 0 at pi. Pi is what, 3.14? We have another value which is what? Well, I should put the pi actually on the left side. Oh no, 3.14 is below the 2. There's another value here which is what? 2.636. And there's another value here which is 3.647. And now you need to find the y value because they are asking for the x and the y value. I'm looking at the picture there on the screen. They want the x and the y value. What is f of 2.636? That's 7 sine 2.636 plus sine 2 times 2.636. You can type the whole thing on your calculator in one shot, and that will give you a number. 7 sine 2.636 plus the sine of 2 times 2.636. 2.543. 543. What's f of pi? 7, yep, sine of pi, which is a 0, plus sine 2 pi, which is also a 0. And the last one, what's f of 3.647? Two times, not x, 2 times. I usually use asterisks for multiplications, so you don't think that's an x. 2 times 3.647. 7 sine 3.647 plus sine, oh, I forgot to close the parentheses, plus sine 2 times 3.647, negative 2.542. There's my 3 points. Now I got to find where's the function concave upward, downward, inflection points, and I'm done. Test point between 0 and 2.6. How about a 1? Between 2.6 and 3.14. How about a 3? Between 3 and 3.6. Yowza. 3.5. Between 3.6 and 2 pi, that's 6 something, about a 4. Take a whole number, make life easy. Plug it into the second derivative. Here's your second derivative in case you forgot. Negative 7 sine of x minus 4 sine 2x. Plug in the 1. All I need to know, positive or negative. So plug in your calculator. Negative 7 sine 1 minus 4 sine of 2. Negative 9.5. That's a negative. Downward. Are you guys paying attention? F double prime at 3. Negative, plug it in. Negative 7 sine of 3 minus 4 the sine of 6. Positive 0.13. Concave upward 3.5. Negative 7 sine 3.5 minus 4 sine 7. Negative 0.17. Concave down. The next one, a 4, negative 7 sine of 4 minus 4 sine of 8. 1.34 positive. Where's my inflection point? Right here. Inflection point. Right here. Inflection point. And right here, inflection point. You get 3 of them. Inflection points. You get 3 of them. 2.636 and 2.54, pi and 0, and 3.647 and negative 2.542. 3 points. Concave upward. From where to where? From here to here, 2.636 to pi, not including these numbers, or union, add to it, from here to 2 pi. Concave downward, from 0 to 2.636, add to it, from pi to 3.647. And I think we got all the pieces. All inflection points, everything. Maybe I'll do one more. I won't be able to do them all. No way. So let me look for something that looks different. (18, 20, 23). Let's see which one of them actually. 18, 20. (23) is the quickest one, so I'll skip it. (18) versus 20. Let's see which one's uglier. 20 is a short one. What's 18? 18 is the tougher one. So I'll go with 18. That's the toughest one out of the three by far. So I'll do 18. (1/9) e to the x minus e to the minus x. Again, the question, find the points of inflection, if any, concave upward, concave downward. I need the first and the second derivative. First derivative. There's the 1/9. What's the derivative of e to the x? E to the x. What's the derivative? There's the minus. What's the derivative of e to the minus x? Minus e to the minus x, right? Because it's e to the u times the derivative u. The derivative u is a minus 1. So you end up with 1/9 e to the x plus e to the minus x. In other words, I don't need a fancy calculator, nothing for that. What's the second derivative? There's the 1/9 in the front. Derivative e to the x, e to the x. E to the minus x, minus e to the minus x. What do you know? Look at that. Same as the function. Where is the second derivative equal to 0? When e to the x minus e to the minus x is equal to 0. E to the x equals e to the minus x. If you want, you can divide both sides by e to the minus x. What's e to the minus x? E to the minus x? 1. And this would be e to what? Could it be 2x? E to the 2x equals to 1. You still want to solve it. That's an exponential equation. How do you solve exponential equation? Take the log, the natural log, absolutely. ln of e to the 2x equals ln of 1. ln and e will cancel each other out. 2x equals the ln of 1, which is what? 0. X equals to 0. Undefined, there's none. It will never exist for undefined for this one. Because even if you make it a fraction, this will never be 0. E to the minus x will be 1 over e to the x. E to the x is always more than 0. So we do not have derivative undefined second derivative.
Why are you going from e to the x plus e to the negative x to e to the x minus e to the negative x?
Where?
From your first derivative to the second derivative.
Here? This one to this?
From there to there on, yeah.
For me, take the derivative of that. Derivative of e to the x is e to the x. And this is minus, because that's the u there,
Oh,
right?
okay.
Yep. So we only have one critical value here. Mr. McDonald, he's always like that. He's a nut. Plus, he can't really hear. You have to yell when you talk to him. He was my teacher in 1978. So, y equals 1/9 e to the x plus e to the minus x. Plus, they're not doing calculus. If they were doing calculus, different story. When I teach pre-algebra, everyone's having a blast because the stuff is not that hard. You come here, everyone's like, oh, I can't horse around because I need every minute of the class time. I just got to focus and go through it, like being in the military. Don't like it? Suck it up and go through it. That's what I have to say. Keep going. We don't have a choice. We don't have a choice, basically. Neither you nor neither do I. I need to cover the stuff. When x is 0, what's y at 0? Add the derivative at 0. 1/9 e to the 0, which is 1, minus e to the negative 0, which is also 1. That's a 0. So I'm going to pick a test point to the left of the 0, like a -1. To the right of the 0, that's a 1. I just need to know positive or negative. This is my second derivative. So what is the second derivative at -1? E to the -1 minus e to the 1. Positive or negative? That's a negative number. You can push on your calculator. Concave downward. What's the derivative of 1? 1/9, second derivative here. E to the 1 minus e to the -1. That's a positive. You can try to get on your calculator there. Do we have inflection point? Yes. Where's the inflection point? 0, 0. Concave upward. From 0 to infinity. Concave downward. Negative infinity to 0. Done. That's all the stuff on that.